We are in chapter 4 and we're starting section 1. The cool thing is that you all get to see inside my book and the markings and stuff that's highlighted and then underlined and all sorts of stuff going on inside my book. But I'm asking you to follow along either in your ebook or in your own hard copy of the textbook. We did find out the other day that someone had ordered the wrong book. This is the brief version. They didn't order that one. And so they're just going to have to adjust. Like when I say that right now I'm on page 194, they're going to need to go look for a page that looks very similar and not get frustrated. Just find it and know it's going to be a little bit different, but they're still going to have the bulk of the material. I do want to read a few things. Again, if we were in class together, I'd be getting you all to read to me. I like that much better. But it is what it is, and here we are. A cynical person, boy, that's funny. A cynical person once said, "The only two sure things are death and taxes." This philosophy, no doubt, arose because so much in people's lives is affected by chance. From the time you awake until you go to bed, you make decisions regarding the possible events that are governed, at least in part, by chance. For example, should you carry an umbrella to work today? Will your car battery last until spring? Should you accept the new job? This chapter is talking about probability. And actually, the title of the chapter is Probability and Counting Rules. I want to encourage you that this chapter has been known to be difficult to understand. So I want to encourage you to seek out tutoring, working with each other, especially in this chapter if you haven't done so already. It's talking about probability, and as a general concept can be defined as the chance of an event occurring. And I'm sure we all might throw in what are the chances or odds that a pandemic would occur and we would all be at home doing school from home. That's got to be an interesting probability. Many people are familiar with probability from observing or playing games of chance, such as card games, slot machines, or lotteries. In addition to being used in games of chance, probability theory is used in the fields of insurance, investments, and weather forecasting, and in various other areas. Finally, as stated in Chapter 1, probability is the basis of inferential statistics. For example, predictions are based on probability, and hypotheses are tested by using probability. You're going to watch two videos made by the author in this section. And one of them is going to start about right here, and the author is going to talk about sample space, which I don't have that on the screen right now. I want to fill in a few of the blanks that when the author is talking about sample space, as you see down here at the bottom, the author is going to talk about a coin, a die, true, false, tossing two coins, and then on the other page, we're going to bring in talking about, sorry, I'm trying to say this quickly and kind of as an overview, and I don't want to leave stuff out. But we're also going to talk about a deck of cards. So as we go on to the top of this next page, which is page 195, I do want to show you some information. I know the author is going to talk about sample space. And so I do want to introduce a couple of objects because on the next page we're going to talk more about simple and compound. But here's a coin. And when you're talking about a coin, I know this is talking about dice. When you talk about a coin, it can land on heads or it can land on tails. You can also do a sample space or an experiment where you're going to toss three coins. And what are the odds that they'll all land on heads or that they'll all land on tails? You get to set up all sorts of different events. This one's talking about die. And so one is a die. Multiple are going to be called dice. And they have 6 sides. They're labeled 1 through 6. So this says, what's the sample space for rolling 2 dice? The big thing I would tell you in this chapter is to not be lazy. I know it's tempting to cut corners and just kind of throw down some answers, but in this situation, I would not be lazy in what you choose to write or choose to think on or choose to spend time pondering. But in this case, it just said, what's the sample space for rolling 2 dice? I would also encourage you, as a big thing for this chapter, is to have patterns. In other words, when we go to roll 2 dice, We need to keep this pattern really simple. And I'm going to start at the beginning because that's a good pattern to start with. We'll go 1, then 2, then 3, etc. But in this case, we could land on a 1 and a 1, and they will put it in parentheses or not, or however you want to do it to keep up with it. But it is possible that a a, a thing that this could land on, that an event, is that we could land on a 1 and a 1. But keeping this in a pattern, I could also land on a 1 and a 2. I could also land on a 1 and a 3. And we can keep this going. And this is where I mean, don't be lazy, don't be shortcutting yourself, because we need to see that there are 6 different possible ways that 1 could be the first die. Well, let's go see what could happen if our first die is a 2. Well, if the first die is a 2, the second die could be a 1. And if the first die is a 2, the second die could be a 2. And hopefully you start to see a pattern that this one's going to keep going down just like the other. And then we're going to do this for a 3, and then we're going to do it for 4, 5, etc. And that's what they have listed right here. It's talking about the sample space, all of the possible outcomes, and it says, can you show them or find them? And when you look at this, we've got 1, 2, 3, 4, 5, 6 outcomes this way, 1, 2, 3, 4, 5, 6. So we have 36 possible outcomes, and our brain has to be able to see that, understand it, get it to make sense. We've got to understand the basics here before we turn the page and keep going. So I'm going to go ahead and understand some more spaces. I want to understand some more sample space in dealing with a card or a deck of cards. I often have students in my class who don't play cards and they don't know about cards, so let's take just a minute. You're going to need to memorize a couple of things about cards. First, 52 is a good number to memorize. There are 52 cards in a deck. Another thing to memorize is that each one of the items, like there are 4 aces, there are 4 twos, there are 4 threes. And if you look right here, you'll see 4 aces, 4 twos, and 4 threes. But then when you go across a suit, and they're mentioning this here, and I said it wrong, 4 suits and 13 cards for each suit. And I may need to pause and get some coffee, but here we go. It says there are 4 suits and there are 13 cards for each suit. And when you're looking at these cards, there are going to be ones that are like the 1, the ace, the 2, the 3. But when you're looking at the suit, you're going to have the clover, and they're going to go all the way up to 9, 10, 11, 12, 13. So they all have 13. So we've talked a little bit about coins, die or dice, and cards. There are going to be other items that you may not be able to see and to touch physically. You're going to need to draw out the idea. The author's going to do an example on gender for children. So I want to go ahead and look at the top of page 196. And at the top of 196, it talks about a tree diagram. He's not going to use a tree diagram, but I want you to notice at the bottom of this page that a tree diagram is a great organizational tool for figuring out how many outcomes and not missing any. I mentioned earlier having a pattern. You need a pattern. You need to be predictable. You need to make sure that whatever you do, you don't miss any possible outcomes. And so what they do right here is a tree diagram, and maybe we need to turn it sideways for it to look more like a tree. But if the first child is a boy, or the first child is a girl, the second child could be a boy or a girl, the second child could be a boy or a girl, and then the third, and you see here, and then notice the outcome is like here being boy, 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 and that's where the author wrote BBB. And this one would be boy, boy, girl. So a tree diagram is very helpful. The author is going to talk about, as it says at the bottom, an event, and it consists of a set of outcomes. And so talking about sample space and our outcomes and drawing these and the possibilities, just like everything that we've been doing in this class, really try to have either flashcards or a glossary page that you have started, but something where you are mulling these ideas over in your brain and you're making them make sense, adding your own words, and just making sure the words you add hold up with everything that you do. But here come some more words. It says here, if a die is rolled and a 6 shows, this can be called an outcome. And since it is the result of a single trial, an event with one outcome is called simple. And if you want to think about simple fractures and compound fractures, simple has one break, compound has 2 or more. And then it mentions when a die is rolled, the event of getting an odd number when a die is rolled, that's compound. Because an odd number, it could mean that you're getting a 1 or a 3 or a 5. That's not just one event, that's multiple events. In general, a compound event consists of 2 or more outcomes, like a compound fracture, 2 or more breaks. I really want you to see this piece here, that there are 3 basic interpretations of probability. The author is going to do a video on classical, and the author is going to do a video on empirical. I'm going to do a couple more videos, and I'll come back around, and then you and I will talk about subjective. But I want to keep showing you that when he talks about classical, he's going to mention a formula. And this formula, I like to throw in a couple of other words. It's the number of outcomes that you want in the numerator. Like if I want an odd number, then I have 3 possible outcomes. It's what I want to have happen. But in the denominator, it's the number of outcomes in the sample space. Like how many possible outcomes are there on this die? Well, there are 6. So I would have 3 over 6, just like throwing in those words of what you want. Down at the bottom of the page, I want to point out that the probabilities can be expressed as fractions or decimals and possibly percentages. And then down at the bottom, it says in this chapter that most of it's going to be fractions or decimals, but we still can use percentages where appropriate. So just watch your directions in this book, in the homework, and on your test. So the author is going to go through several pieces, several thoughts, several ideas. I want to go ahead and go through a few of these in this video. And so looking at this first one, and by the way, I hope you've got the right book. I'm going back to where we were and leave my sticky note. I hope you do have the same book as I do. I'm on page 198, and I want to look at this first one, example 4-5 of drawing cards. I'm going to cover all of this stuff up. And again, this chapter can be a very challenging chapter. So do not gloss over, or speed through anything that we're doing. Get it to where it really makes sense to you and where you could redo the example without using any notes. So it says, find the probability of getting a black 6 when one card is randomly selected from an ordinary deck. Back over here, it's the probability, and you can't see that part, the probability of an event happening. Where is it? There it is. The probability of the event happening. And then we're going to do in the numerator what we're wanting to have happen over the total amount of things that can happen. So I'm going to say the probability of. We want the probability of getting a black 6. Not just a 6, not just a clover 6, or we used to call them puppy feet, but a black 6 when one card, we're not trying to do anything multiple here, like drawing 3 or 4 cards, is selected from an ordinary deck. So in the numerator, we're going to put the amount of items that we want. How many of those are loitering around in the deck? And so I'm thumbing through my card deck real fast. And when it says a black 6, I can't just think clover. I've got to think there are 2 of them. And so with there being 2 of them that would satisfy what I want, I then need to put it over how many things are even in what we're about to go draw from. And there are 52 things in what we're looking at. It doesn't tell us to leave it as a fraction. It doesn't tell us to turn it into a decimal. But one thing that you should always do is to reduce. If you feel shaky on fractions, this is definitely something you might want to follow up using some other resources. But we need to reduce this. Don't dare do 52 divided by 2 and come up with 26. It's actually 1 out of 26. So looking here at what they have, right here, the 2 out of 52, 1 out of 26, and then they go ahead and take it to a decimal, which is not a bad idea just to practice and see that you're punching in information correctly. So I'm going to go ahead and cut on my calculator, and I'm going to type in 1 divided by 26. Make sure you don't do it upside down and do like 26 divided by 1. I got 0.03846. They rounded to the third decimal place, 1, 2, 3. And that 8 is where they rounded to, but that 4 is less than 5, so we leave it alone at the 8. And we have a correct rounding. So looking here, we were talking about cards. You've got to memorize that 52 in a whole card deck. He's going to do an example about the gender of children, and I want to scooch on down the page where it says, in probability theory, it is important to understand the meaning of the words and or. And for this whole chapter, it's going to be vital that you understand and or. And it's going to mention some other things like the word or has two meanings. For example, if you were asked to find the probability of selecting a queen or a heart when one card is selected from a deck, you would be looking for one of the 4 queens or one of the 13 hearts. And in this case, the queen of hearts would be included in both cases and counted twice. So you're going to have to do something like where you add up the 4 and then the 13, but then take away the 1 overlap and have 16 possibilities. This would be a great place to pause the video and think on that for a moment. It says in the first case, well, I should say this. On the other hand, if you were asked to find the probability of getting a queen or a king, you would be looking for one of the 4 queens or one of the 4 kings. And in this case, it's a 4 plus 4 or 8. In the first case, both events can occur at the same time. I should have this highlighted and like with little stars around it. We say that this is an example of inclusive or. And in the second case, both events cannot occur at the same time. And we say that this is an example of exclusive or. Again, this would be a great place for you to pause and think on that for a moment. I am going to do a couple of examples. Remember, I'm not doing everything in our chapter, and it would be good for you to go back and to redo, think on, look at, work through several of the things that I don't do. I am going to start at the bottom of this page. I'm at 4-7. And example 4-7, it says a card, A. That's a huge word to hang on to. A, 1. Not I'm going to draw 3 in a row, nothing like that yet. We got to understand what it means to draw a card. From an ordinary deck, nothing weird. It would be good if they even said we removed the jokers, but they didn't say that, but we removed the jokers. Find the probability of getting. And so I want to play around with these. And so starting with the first one, it says A. What's the probability of getting a heart? Probability of getting a heart. So remember in the numerator, we have to put how many are even in the deck of what we want. Hopefully, you have remembered that for each suit, there are 13, because it's going to take me a while to go find all of these. But they want us to be able to reach into a deck, a bag, or something, and randomly draw out a card. And what are the odds? What's the probability that we're going to reach in there and get one of those 13 cards? Well, there are 13 hearts sitting in that deck out of how many in the deck? 52. And you got to memorize 13 is great because there are 13 hearts, there are 13 jacks, there are 13 spades, and 13 puppy feet. Can I find one of those real fast? And so with that in mind, there are 4 groups. And with there being 4 groups, that makes this pretty easy, that 13 goes into 13 once, and 13 goes into 52, 4, and that puts us at a fourth. Or if you wanted to convert it to a decimal, depending on the directions, you would say 0.25. B is just like what we did. I'll leave that one for you. C, what's the probability of getting the 8 of diamonds? What's the probability of getting the 8 of diamonds? So I'm going to thumb through this deck about as fast as I can thumb through it. And my brain is thinking, 8 of diamonds, 8 of diamonds, 8 of diamonds. How many 8 diamonds are in this entire deck? 1. Well, how many cards are in this entire deck? 52. We're done. I can't reduce that. I can convert it to a decimal, but I have now found the probability of drawing an 8 diamonds. I'm going to go ahead and do E. I'll leave D for you to do. But on a face card, what's the probability of getting a face card? Well, a face card, that's a different way to look at these. So a face card, that's going to be the Jack, Queen, King. And we know from earlier that there are going to be 4 Jacks in a deck, there are going to be 4 Queens in a deck, and there are going to be 4 Kings in a deck. So 4, 4, and 4, there are 12 face cards in a deck out of 52 cards in a deck. And that's not that cute 13 from a while ago, but they are evens. So I can take out a 2. I can take out another 2, and I am done. I can convert it to a decimal, but everything that we just talked about in this pretty long video, 21-ish minutes, make sure that you've started, stopped, paused, thought, written down, taken great notes on our first part of Chapter 4, Section 1.